Good morning, one and all. Myself, Dr. Maheswara Rao, Department of Civil Engineering, Institute of Aeronautical Engineering, Dundigal. Our course name is Fluid Mechanics, and today's topic is micro manometers. So here, first, manometers. So what is the manometer means? We can measure the pressure in any system. So if a fluid flows in a pipe, so you can measure the pressure existing in that pipe due to the fluid. Those devices are called manometers. So we have already dealt U-tube simple manometer and a differential U-tube manometer. Okay. So U-tube manometer, simple manometer is to measure the pressure inside the system. Whereas U-tube differential manometer, we can measure the pressure difference between 2 points. That is a U-tube differential manometer. Differential means the difference of pressures between 2 points, any 2 points. Today we are going to learn this micro manometers. So what is the meaning of micro manometers? Micro itself shows very, very low values. So if the pressure is very pressure fluctuation or pressures are very less, then how can you measure the low pressures? That is, the device used here, it is called micromanometer. So before going to the topic, the course outcomes, that means students will be able to do or will be understood the following. Among which CO1, that is course outcome 1 in this course is, the students can define the fluid and their properties and surface tension, all those things they will get the knowledge. That is course outcome 1. Whereas course outcome 2 is the Newton's law of viscosity or classification of fluids. So how these fluids are classified? Based on the Newton's law of viscosity. So Newtonian fluids, if it is obeys Newton's law of viscosity, if it is not obeys, the fluid is not obeying the Newton's law of viscosity, that is called non-Newtonian fluids. So here, what is viscosity and related problems also dealt in this course outcome 2. And course outcome 3 is the capillary rise or fall. So whenever you insert smaller diameter tube, the fluid will rise. Some of the fluids will rise more than their original level. So if it is a tube, so this will rise here. So which is called capillary rise. Some of the fluids, if you insert smaller diameter pipe, so its level will be reduced. So actual level is this, the tube's level is this one. So this is called capillary fall. So those knowledge will be in course outcome 3. So course outcome 4 is the surface tension. So any fluid, the surface will maintain a tension. So that's why it is called a surface tension, and their applications will come in the course outcome 4. Course outcome 5 is the compressibility. So if you apply external force on any fluid, if the volume changes, then it is called compressible fluid. If volume is not changing, that is called a incompressible fluids. So example, gases are compressible fluids and water is incompressible fluids. So that is the compressibility. So if volume changes, density also will change. So in other words, if density changes, then it is called a compressible fluids. If density is not changing, then it is a incompressible fluids. Examples, gas for compressible fluid and water for incompressible fluids. And last one, course outcome 6 is the pipe flow or fluid friction. So whenever a fluid is traveling, moving inside a pipe. This is a pipe. So this is a fluid. So at the surface of the inner surface of the pipe and the fluid surface, because of the movement of the fluid, so there will be frictional forces. So whenever it is moving the fluid, it will lose some energy because of the frictional losses. Okay, the pressure will lose, all the energy will be lost. So that is course outcome 6 related to pipe flow or fluid friction. Now today's topic is micro manometers. So already I told you micro means it is very small. So if it is pressure is very small, then we will utilize these micro manometers. Okay, we see this micro manometers are the precision instruments, very precise instruments, very small pressure differences we can measure here with high accuracy. Okay, that is the purpose of the micro manometers. Okay, if the pressure differences are too small and we want accurate measurement, so we can use these manometers. So the figure shows the micro manometer. So here is a system pipe in which fluid is flowing, and you want to know measure the pressure at point A. So which is a PA. And here is a reservoir, it is a small tube. So normally the area of this reservoir is capital A, the area of this tube is called small a. So the small a, the capital A, that means area of reservoir will be 100 times the area of this right limb. So here it is about datum. Here you can see this is a datum. So this datum line above the point A is at a distance of H1. This is H1. At the same time, in the right limb, it is H2 from the datum line. Okay. So whenever pressure is applied due to the fluid from pipe A, so this reservoir level will goes down. So small quantity. It is very small. That's why you can take it as a delta H. So for a delta H of fall in the reservoir of the manometer fluid, so there will be rise in the right limb. So then how we will calculate, we can see it. See, this is a pressure at A pipe. This is H1 from the above the datum to the point A in the pipe. And H2 is also the height of column in the right limb from the datum. Delta H is the fall in the level of the reservoir due to pressure of the pipe. So here it is S2, this is S1. So what is S1 here? Specific gravity of the fluid present in the pipe. And whereas S2 is the specific gravity of the manometric fluid. Construction. So how it is made. Okay. If you see it, a micro manometer consists of glass. Okay, glass or transparent tube. So here, these micro manometers are manufactured or utilized by using the glass material or a transparent tube also. So often in the shape of U, it is also a U shape, just like a normal tube manometer, differential tube manometer, it is also a U shape. Okay. So standard, similar to the standard manometer, but designed to measure the minute differences in pressure. So it is very similar to normal tube manometer, but it is meant for to measure the minute differences, minute pressures. Okay. So the tube is filled with the manometric fluid. So here manometric fluid is there. What type of manometric fluid we are using? You can see now. Typically liquid with low density. So what type of manometric fluid we are using? We are having mercury is there, water is there, so oils are there. Here, the manometric fluid is alcohol. Okay. So, in micromanometers, the fluid, manometer fluid is alcohol, or we can also use water or a light oil. This can be utilized as a manometric fluids in the micromanometers. Okay. So then the limbs of U-tube may be connected to reservoirs, okay, or precision scales that allow for the accurate measurements, small changes in fluid height. Now we can see the construction of micromanometer. Sensitivity. So what is the sensitivity? See here. Micromanometers are designed to be highly sensitive. So very highly sensitive, small pressures, small differences also, it will catch the readings. Okay, capable of detecting very small changes in pressures. Okay, it is capacity to recognize very small changes in the pressure. So often in the range of micrometers or less. So that's why it is called micromanometers. So micrometers or less, even less value also it can read. So this is achieved through a use of very light manometric fluid. How will you get this? You have to make it a very sensitive, highly sensitive means by placing a very light manometric fluid like alcohol, etc. Then working principle is very similar to the U-tube manometer or differential U-tube manometer also. So what is the working principle here? Hydrostatic principle. So what is the hydrostatic principle? It tells that pressure at any point in the fluid. So pressure at any point in the fluid is nothing but the weight of the fluid above it. Okay. So if you want to find out the pressure at here, it is nothing but the weight of this fluid column above that point. That is the pressure. It is the hydrostatic principle. So working principle of micromanometers. See here, small pressure differences. Small pressure difference when connected to 2 points in a fluid system. Okay, 2 points. Even small differences in pressures will cause a corresponding difference in the height of the manometric fluid in the U-tube. So this difference is measured with high precision. So even if it is connected between 2 points, so even small difference in pressures also we can measure very precisely at high precision by using these micromanometers. So mathematically, if you see the expression, okay, pressure difference calculation, about delta P is equal to rho m minus rho s into GH. So where rho is the density, m is for manometric fluid, rho m is the density of manometric fluid, rho s is the density of the fluid for which the difference is to be measured. So G is equal to acceleration due to gravity, and H is the height of the fluid columns. That means a difference in height of the fluid columns in the U-tube. Okay. So then, if you see the formula for this, it is a system. It is connected to reservoir, and again reservoir is connected to right limb. Okay, so it is a datum. So from datum, point A height is h1 and height in the right limb is h2. Okay, so here one thing is there, volume is equal to similar. So whatever the volume displaced in the reservoir, the same volume will rise in the right limb. So what is the area here? The reservoir. This is the reservoir. So capital A is the area of the reservoir. Delta H is the fall of fluid in the reservoir. So capital A into delta H gives the volume of the manometric fluid displaced in the reservoir. So similarly, in the right limb, small a is the area of this pipe. Right limb, small a is the area of the right limb, and H2 is the height of manometric fluid displaced. So both these volumes must be equal. So then capital A delta H is equal to small a H2. Okay. So then if you see the pressures, then PA, that means pressure in pipe A, point A, plus, so that is the pressure in the pipe, plus rho 1G H1. Rho 1G H1. Rho 1 means nothing but the density of the fluid in the left limb pipe. G, the acceleration due to gravity. Delta H plus H1. So initially from datum it is H1 and the small difference is delta H. So total height is delta H plus H1. So if you see the right limb, so then it is also rho GH. So rho means here density of the manometric fluid here. So G is the acceleration due to gravity. Here also H plus delta H. So whatever down here, same thing will be there. So H2 plus delta H. So these two pressures must be equal, because then only the system will be in equilibrium. Here atmospheric pressure will act. Then if you take this rho 1G delta H plus H1 to the right side of the equality, then PA is equal to delta H. And you're taking common. So if you're bringing this side, so it will get minus sign, and taking common delta H. So what will you get? Rho 2G minus rho 1G plus rho 2G H2 minus rho 1G H1. So just you bring this part to the right side of equal symbol. Then take the common delta H. Okay, this is the delta H. So then you will get this type of expression. So whereas delta H, you can see from this volume, equal volume, delta H, okay, A into delta H is equal to small a into H2. Then delta H is equal to small a by capital A into H2. H2. So this we will substitute delta H is equal to small a by capital A into H2. Then you will get this formula. So pressure in pipe A is equal to small a by capital A into H2 into rho 2G minus rho 1G, rho 2G H2 minus rho 1G H1. So this is the formula. But if you see this small a by capital A, okay, it is very, very small. Okay, the right limb area is very, very small compared to the reservoir area, this area. So that we can neglect that term. So what is the term here? AH2 by A and rho 2G into rho 2G minus rho 1G. So this whole term you can neglect. So what is the remaining now? PA is equal to rho 2G H2 minus rho 1G. Then if you take an example for this micromanometer, so let us take, so we can solve some problems based on the references. Okay. So now if you review the things, then micromanometers are nothing but the devices utilized to measure the small pressure differences, very, very small pressure differences with more accuracy. So what is utilized to get that? We are inserting some extra reservoir, which is very, very big compared to the right limb. So because of that insertion of reservoir, very nearly more than 100 times the area of the right limb. So that's why you will get the very, very low pressure differences also by using these micromanometers. Here micro means micrometers. Okay, so if you can measure the micrometer values of the pressure differences by using these manometers. So you are having here you can see one datum. Okay, so it is a datum and it is measured H1, and from the same datum right limb is measured H2, and this is a reservoir area is capital A, the right limb area is small a, and S2 is the specific gravity in the right limb, and S1 is the specific gravity of fluid in the system. So here you can see the figure of micromanometer. So it is a pipe, fluid is there, pressure is PA, H1 is the height of the point K above the datum line, and HT is the height of the manometric fluid above the datum line. Capital A is the area of the reservoir, small a is the area of right limb, and S2 and S1 are the specific gravities of fluids present in the pipe, left limb and right limb respectively. And if you see the construction, so just like normal YouTube manometer or differential manometer, okay, this is also a glass material, or even you can use as a transparent tube also. Shape is U shape. Okay, so it is very similar to standard manometer, but designed to measure the minute differences in pressure. Okay, so here manometric fluid will be normally alcohol. That means a very low density manometric fluids we can utilize here to get minute differences in pressures. So limbs of U-tube connected to reservoirs for pressure scales are for more accurate changes. Then construction of manometers. Here a sensitivity is there. So it is very, very highly sensitive. Okay. So you can measure capacity to measure for detecting very, very small changes in pressures. Okay. So even in the range of micrometers or less. So how to get this? By using the very light manometric fluid. The working principle is very similar to your normal U-tube manometer or differential U-tube manometer. The principle is that the pressure at any point is nothing but the weight of the fluid from that point, weight of the fluid above the point where we are measuring the pressure. So that is the hydrostatic principle. And it is connected to, if you want to know the difference 2 points in a system, so we will connect to the micromanometer. So we can measure the differences with highly precision. The formula is like this, and if you see this small derivation part, okay, so this is the area of reservoir. You can see here, capital A is the area of the reservoir. This is the reservoir. Delta H is the fall of micrometer fluid, and small a is equal to area of right limb. H2 is the height of that means manometer fluid above the data. So if we equate the pressures in the left limb and right limb, this is the pressure inside the pipe, this is the pressure in the left limb, this is the pressure in the right limb. So if you do small, taking right side of this is equal and taking common delta H, you will get this rho 2G delta H into rho 2G minus rho 1G plus rho 2G H2 minus rho 1G H1. So then, but in the place of delta H, because first equation, capital A delta H is equal to small a delta small a H2. Therefore, the delta H is equal to small a by capital A into H2. So you can replace delta H this. You will get this equation. But is to see the area of right limb is very, very small compared to the reservoir area. Hence, you can neglect the term which is attached to the delta H or small a by capital A into H2. So then the remaining part is rho 2G H2 minus rho 1G H1. So by placing this, we can measure the pressure in the pipe A. So references. So here K. Subramaniam, Theory and Applications of Fluid Mechanics, Tata McGraw Hills 2012, and Modi PN and Nelson Seth, Hydraulics and Fluid Mechanics, Standard Course 2002. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.